Once again, welcome. We are adding on the questions that we had done, and we are given this arrangement, and you are required to find the effective capacitance of the arrangement or the total capacitance, the charge stored by each capacitor, and finally the PD across each of the capacitors. So without wasting any more time, let us begin by asking ourselves which capacitors are in series, which ones are in parallel. Okay? And you can see that this capacitor, this one of 2 microfarads, is in series with the supply PD, and can be in series with all these ones if they are combined together. This and this are in series, but then they are in parallel with this, right? Because the same current passes through this and this, but you see a current divides. Okay? So what we can do is the effective for C3 and C4, C3 and 4, the effective, since they are in series, is a product out of sum. 5 times 5 out of 5 plus 5. This is 25 out of 10, and that would give us 2.5 microfarads. Meaning that this arrangement could as well be represented by this diagram that I'm drawing. It has a capacitor here, it has a capacitor there, and it has a capacitor there, right? Yes, where this is of course 90V, this is 2 microfarad. You realize that this and this, of course here we have got 2.5, so this is 1.5 and this is 2.5. So this 1.5 and 2.5 are in parallel. Therefore, the effective of these two, the 1.5 and 2.5 are in parallel. So the effective is, we just do what? We just add them, which gives us 4 microcoulombs. This takes us to this other diagram, that this is now an equivalent of us having, this is our source, this is now the capacitor that we have been having, and then this one. So this is 4 microfarads and this is 2 microfarads. So these are 2 capacitors which are in series with each other and in series with the PD that we are supplying. How do we get the effective capacitance? Finally, the capacitance of course is product out of sum. This is 8, this is 6, so that is 8 out of 6, and that will give us 4 out of 3 microfarads as the effective capacitance. And therefore our arrangement can be like this. This is the capacitor of 4 out of 3 microfarads, and this is 90 volts. Now, if that is so, what is the total charge? Because you must calculate the total charge, by the way. The total capacitance, the total capacity. So we already have. So the total charge is CV, and this is the capacitance is 4 out of 3. Then the voltage is 90. This is 4 out of 3 microfarads, then times 90. And when you press on your calculator, you should be able to get the total charge as 1.2 exponent -5 coulombs. Yes, should be able to get that. We have got the total charge, but we want the charge stored by each capacitor. You can realize when you come here that this capacitor and this capacitor will store the same charge and will store this. This was this one. So meaning the Q1, if Q1 is the charge stored by capacitor 1, will not change from this one. We have Q1, we need Q2, Q3, and Q4. You also realize that this Q on this capacitor is also the same as that. But this capacitor is an effective of these two, which is an effective of these three. So what does it show you? It shows you that we have to first now, we can now come to this diagram, okay? We come to this diagram. This of course was C2, this one, so this will be Q2. And as you can see from this diagram, this one will be from this C3 and C4, but it will be equal. The C3 will be equal to the C4. So I can say that the Q3 is equal to Q4 because they are in series. So I can decide to call this one Q3, right? Yes, I can call this one Q3. So the charge on this, I can call it Q3, which is Q4. Now, what do you realize? You realize that the Q3, the Q2 plus Q3 equals this charge on this one, which is this one, right? So the Q3, the Q2 plus Q3 is equal to 1.2 exponent like 5. Okay? You also realize that the voltage across this is equal to the voltage across this, but V is 2 out of C. Therefore, Q2 out of 1.5 equals Q3 out of 2.5. If I cross multiply this one here, I'll get Q3 equivalent to 2.5 out of 1.5 of Q2. Okay? So that if I bring this one and I press it there, so I have Q2 plus 2.5 out of 1.5 Q2 equivalent to 1.5 exponent negative 5. So when you press on the calculator dividing by this, because I think this one can be something like 5 out of 3, then this is 1, and whichever, okay, when you put in that kind of calculation, I would not want to go there, but if you wanted me to do that, then I can still handle, because if I can work on this, then if I multiply by 2 here, this will be 5, this will be 3. So I say Q2 plus 5 out of 3 Q2 is 1.2 exponent negative 5. So, and if I work out this, the LCM is 3, so this will be 8 Q2. So this will be 8 out of 3 Q2 is 1.2 exponent negative 5. So how do we handle that? I divide by 8 out of 3, divide by 8 out of 3, and I'll be able to get Q2 equivalent to, when you press on the calculator, you should be able to get your Q2 equivalent to 4.5 exponent negative 6. 4.5 exponent negative 6 coulombs. Then what is Q3? Q3 is here. Is 2 is this, or is 5 out of 3 Q2 is 5 out of 3 times Q2, which is 4.5 exponent negative 6 coulombs. And that one will give us 7.5 exponent negative 6 coulombs. What don't we have? Because Q4 is also equal to, this was 7.5. Q4 is equal to Q3. We have Q2, we have Q1. So we have been able to get the charge stored by each of the capacitors. After getting charge stored by each of the capacitors, the last question is the PD across each of the capacitors. The PD across each of the capacitors. So I just have charge stored and the capacitance. So from Q is CV, I have V as 2 out of C. Therefore, V1 is Q1 out of C1. Q1 is 1.2 exponent -5. C1 is 2 exponent -6. So 1.2 then divided by 2 exponent -6. Yeah, I think it should give me 6 volts. Okay? V2 is Q2 out of C2. The Q2, we have it. The Q2 is 4.5 exponent -6, and C2 is 1.5 exponent -6. Ideally, 4.5 out of 1.5, I think should be giving you 3 volts. V3, the third one is this. You see, this is 5 microcoulombs, 5 microcoulombs. So they are the same. I know the same voltage will be across this and this. They store the same charge, and then they have the same capacitance. So V3 is Q3, 7.5 exponent -6 out of C3 out of 5 exponent -6. And when you get 7.5 and then you divide by 5, you shall get 1.5 volts. And finally, the V4 will be 7.5 exponent -6 out of 5 exponent -6, which gives 1.5 volts, because the V4 is the voltage across this one. Of course, the charge across this one, the Q4 is there, so we just substitute. Or this one can be found at back science education consultants, where the continuity of learning must take place. Don't be selfish. When you get something good, share it with others. There is one great woman in the Bible. After receiving good news that she was carrying a baby who was going to be the savior of the world, she had to run and visit her sister, who was a cousin. That sister was close to 100 years and she had never produced any child. But by the mercy, don't ask me more about that, ask your leaders in your religion. But by the mercy of the Creator, that old woman also became pregnant. As this one is pregnant of the Savior, the other one is pregnant of who will provide a way for the Savior. That is taking good news. What do you take? Please, can you take good news to others? Can you share this channel with others? Share the link, share the videos, just send on Facebook, Twitter, Instagram, or on WhatsApp. Send on all the social media, send in all the groups on WhatsApp, so that someone there may be longing to meet, to get such a lesson, but cannot access them. When you do that, I know you are going to enjoy a lot and you will have helped more. By doing so, you are an agent to this evangelization of understanding physics, so that we build the nation together. I have a question for you at Back Science Education Consultants. I am not sure how you can scan through it. I'm not very sure. If it's possible, you will get it. If it's not, then you can listen to what I'm going to read. Then you'll still get it. But our simple question is right there. Okay? Our simple question is right there. If it is possible that you can scan through, the better. Okay? If it is possible that you can scan through, the better. If it is not, I'm again reading through. Okay? But I'm sure you can scan through this. I'm sure you can scan it and then do those questions and try out on your own. I can read that 3 capacitors of capacitances 4 microfarads, 6 microfarads, and 12 microfarads. I said 3 capacitors of capacitances 4 microfarads, 6 microfarads, and 12 microfarads are connected in series across a 6V DC supply. Calculate part A, the charge on 12 microfarad capacitor. Part B, the total energy stored in the capacitors. And part C, the PD across the 4 microfarad capacitor. 3 capacitors of capacitances, 4 microfarads, 6 microfarads, 12 microfarads are connected in series across a 6V DC supply. Calculate the charge on the 12 microfarad capacitor, the total energy stored in the capacitors, and the PD across the 4 microfarad capacitor. For the part of the total energy, me challenge you, feel free to leave it. One of the lessons that are following, you are going to handle that. Otherwise, I thank you very much for attending our lessons, and I request that please share with others so that they can be part of this. I'm Teacher cont'd, the MC, who is actually making you pass through all of this. I pray that you will understand all this so that any number that comes on capacitors, you have the capacity to get 20 out of 20 as you prepare for that D1 in physics paper 2, as you prepare for that super A of 111 in physics. Be blessed.